what's up guys, and welcome back to this tutorial on the 2018 GDE exam. So we're going over question 5. Okay, it's a relatively short question. It's about work. It's basically about work and energy, maybe a bit of Newton's laws. Okay, but let's get into the question. So a load of 75 kilograms is initially at rest on the ground when, so it is then pulled vertically upwards at a constant acceleration of that amount by means of a light rope. Refer to the diagram, ignore air resistance, rotation, and the mass of the rope. Okay, so we know the displacement and everything. Okay, so question 5.1. Okay. So draw a labeled free body diagram of the load while it is moving upwards. Okay, so for our load, okay, so there's definitely a weight that is acting downwards and the tensional force acting upwards. Okay, and it might be worth putting in here that tension is greater than the weight because we know it is moving upwards. So you should draw those arrows accordingly. The arrow for tension should be greater than the arrow for weight. Okay, and we get 2 marks for that. Question 5.2, name the non-conservative force acting on the load. Okay, so weight is a conservative force, whereas tension is not. So the non-conservative force is our tensile force or our tension force, and we get a mark for that. Then it says, calculate the work done on the load by the gravitational force when the load has reached 12 meters. Okay, so we want the work done by the gravitational force. Okay, so work is equal to our force times our displacement, right? So our force due to gravity is mg times our displacement. So our mass is 75 kilograms. Our value of gravity or gravitational constant is 9,81, and the displacement is 12 meters. So we get that our work is equal to 8,820 joules. Okay, so remember that work is a scalar, right? So what we should note, just for when we're continuing with the question, is that the work is acting in the opposite direction of the force. So the work, this is in theory, the work here is actually minus 8,820 joules. Okay, but work is a scalar, so don't forget that. So it comes out positive, but we just need to know that it's acting in the opposite direction to what we're actually trying to get it to do. So it needs to be taken into account, the sign. Okay, so question 5.4 is a definition. So it says state the work-energy theorem. So question 5.4. Okay, so the work-energy theorem says that the work done on an object by a net force is equal to the change in kinetic energy, or EK, delta EK, so change in kinetic energy. Okay, so basically what we get from this, question is that the work net is equal to our delta EK. Okay, so that's the formula we get out of that, and we get 2 marks for the definition. Okay, so question 5.5 says use the work-energy theorem to calculate the speed of the load when it is at that height. Okay, so what we need to get is our network, so our work net is equal to our delta EK, so change in kinetic energy. Okay, so we already know what the work done by the so we already know what the work done by gravity is. So what we now need to do is work out the work done by our tensile force. Okay, so basically what we need to do is do a Newton's second analysis of this free body diagram, of this diagram right here. So using Newton's second law, we can say that let me do it next to it actually, we can say that the sum of the forces in the upwards direction is equal to the mass times the acceleration. Okay, so our forces, sum of the forces is going to be our tension minus our weight is equal to our mass times our acceleration. Okay, so we want to solve for our tensile force, so tension equals weight, which is equal to mg plus mass times our acceleration. So our tensile force is equal to our mass times our gravity plus the acceleration we experience. Okay, so the mass was 75 kilograms. The force due to, the acceleration due to gravity is 9,81, and the acceleration it experiences is 0.65 meters per second. So we get our tension force is equal to 783.75 newtons. Okay, so now we know what our tensile force is, so now we can say that our work net is equal to our work of tension minus the work of gravity, which is equal to our delta EK. So work of tension is going to be equal to 783.75, which is what we calculated. Remember, work is equal to force times displacement, so the displacement is again the 12 meters, so times 12 minus the work due to gravity, which is what we calculated here, which is 8,820 minus 8,820 is equal to a half times my mass times my change in velocity. So velocity final minus velocity initial. But we also know that our velocity initial was at rest, so V initial equals 0, so that term goes to 0. We know what the mass is, so we can fill that in as 75 kilograms. And so what we're left with is only one unknown here, which is that value right there, which is our velocity final. And so we can solve for that, and our final velocity is equal to 3,95 meters per second. Now the question is, okay, so again it wants speed. Speed is a scalar, but if it wanted velocity, so instead of speed, if we wanted velocity, velocity is a vector, so we just give it a direction, which would be upwards. But the question only asks for the speed, so this would be our final answer. We do not have to give a direction. Okay, and that's our 13 marks for that question. So yeah, thanks for watching, guys. I hope you found this useful, and in the next video I think we will be going not onto question 6, but onto question 7. Okay, thanks for watching, guys.